Good afternoon students, that is EC 8553 discrete time signal processing. Now we see about IIR filter design unit 2. So here the filters are used to remove or to reduce the strength of unwanted signals like noise and to improve the quality of required signal. To use the channel's full bandwidth, we mix up two or more signals on transmission side and on receiver side. We would like to separate it out in efficient way, hence filters are used. So finally, we have to reduce the strength of unwanted signal and remove the unwanted signal. So thus the digital filters are mostly used in removal of undesirable noise from the desired signal, equalization of communication channels, signal detection in radar, sonar and communication, performing spectral analysis of signals. Then difference between analog filter and for the digital filter. So analog filter are used for filtering analog signals. Here the digital filters are used for filtering digital sequences. Analog filters are designed with various components like resistor, inductor and capacitor. Digital filters are designed with digital hardware like flip-flop counters, shift register, ALU and softwares like C or assembly language. Analog filters are less accurate because of component tolerance. Here the digital filters are less sensitive to the environmental changes. Then less flexible for analog filter. Digital filter, these are most flexible as software programs and control programs can be easily modified. Several input signals can be filtered by one digital filter. Analog filters are represented in terms of system components. Digital filters are represented by the difference equation. And an analog filter can only be changed by redesigning the filter circuit. A digital filter is programmable, that is its operation is determined by the program stored in the processor memory. This means the digital filter can easily be changed without affecting the circuit. Then structure of realization IIR system. Here the IIR filter are of a recursive whereby the present output sample depends on the present input, past input and output samples. Okay. Whereas the FIR filter are non-recursive type whereby the present output sample depends on the present sample and the previous input. That is the difference IIR and the FIR. So types canonic structure and the non-canonic structure. The canonic structure, if the number of delays in the structure is equal to order of the difference equation. Non-canonic structure, if the number of delays in the structure are not same as order. IIR filter transfer function, we know that LTI system are described by the following difference equation as y of n equal to minus summation k equal to 1 to n, ak y of n minus k plus summation k equal to 0 to m, bk x of n minus k, taking z transform on both sides, left side and right side. Y of z, at a time it can converted as y of z, that is equal to minus summation k equal to 1 to n, ak z power minus k into y of z, isn't it? Then plus summation k equal to 0 to n, bk z power minus k x of z. Then we bring the odd term and rearrange the equations. Up y of z plus summation k equal to n. So minus term, if come to the left side means it is automatically changed in the plus. Y of z plus summation k equal to 1 to n, ak z power minus k, y of z equal to summation k equal to 0 to n, bk z power minus k into x of z. So we have to arrange the equations, y of z in the left side, then x of z in the right side. So finally, y of z common no for the left side. So y of z 1 plus summation k equal to 1 to n, ak z power minus k, that is equal to summation k equal to 0 to n, bk z power minus k into x of z. So finally, h of z equal to y of z divided by x of z. So summation k equal to 0 to n, bk z power minus k whole divided by 1 plus summation k equal to 1 to n, ak into z power minus k. This is the h of z transfer function. It is used for the IIR whole terms. Okay. Then we move to a digital filter can be implemented with a variety of structure. A structure can be represented using either block diagram or signal flow graph. The block diagram representation of digital filter consists of unit delays, the multipliers and adders. Now we see about adder one by one. Adder equal to x1 of n plus x2 of n. Finally we get y of n equal to x1 of n plus x2 of n. Then multiplier x of 1 n into x2 of n equal to y of n equal to x1 of n to x2 of n. Then direct inverting section, x of n a equal to some output y of n equal to a into x of n. Then delay elements, x of n z power minus 1, y of n equal to x of n minus 1. If we consider z power minus k means y of n equal to x of n minus k. Then time advance elements, that is x of n equal to z now, y of n equal to x of n plus 1, x of n equal to z power k now, y of n equal to x of n minus k. This is the basic realization block diagram. Then IR filter can be realized in many forms, that is a direct form, 1, 2, cascade form, parallel form, transform, direct form, lattice, ladder structure like that. Then direct form 1 structure, we have a transfer function already, we know h of z equal to y of z by x of z. Then the rational system function h of z can be represented as cascade of two system, means that is h of z equal to h1 of z into h2 of z. Then h of n z we can written as w of z divided by x of z, that is equal to bk z power minus k from the equation. Then we can written as y of z divided by w of z, means the term is changed, isn't it? That is 1 divided by 1 plus summation. Then finally we get the result h of z equal to y of z by x of z, means that is b naught plus b1 z power minus 1. Like that we get the result. Right, this is the direct form 1 realization structure. b naught, b1, b2, b3, bm minus 1, x of n. So finally get the w of n. W of n equal to b naught x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus b3 x n. And so the same way we have to define the h2 of z. So if it is combined, means finally we get the direct form 1 structure. Okay, thank you.